Hey everybody, welcome back to week 4 in our ongoing course into Android development. This week, we're going to be taking a look at how we can add a new activity to our application, how we can navigate to that new activity using an intent. We'll also discuss some of the ins and outs of intents, including the difference between an implicit intent and an explicit intent. Then we'll introduce a couple of new UI elements, specifically menus and dialogues, and we'll work with those to build out a simple menu for controlling whether or not to show our temperature data using Fahrenheit or Celsius. And then finally, we will introduce the concept of persistent data storage, and we'll use shared preferences to save a setting that controls whether we show temperature using Fahrenheit or Celsius. So let's go ahead and jump over to our slides for this week's lecture. Just to give us a quick overview, we'll start with a quick project demo showing what we will build this week. Then we'll jump into using multiple activities, how to create and navigate additional activities within our app. Then we'll explore menus and dialogues and see how to create and show each of those types of elements on the screen. And finally, we'll wrap things up by exploring shared preferences and how to save and retrieve simple key value data using the Shared Preferences API on Android. And then finally, at the end, we will walk through the coding assignment for this week and show you how to implement all of this stuff in your weather app. So now let's take a quick look at what we will be building this week. So this is roughly what our app should look like. We're going to create this new activity, this new screen here called Forecast Details, and it's going to display clicked weather data in what's known as a details view. Essentially, this is going to allow us to click on a list item and then expand the data for that forecast and show it all here in the Forecast Details screen. Then we're going to add a menu. And when we click the menu item, we're going to show a dialog like the one in the second image here. And that dialog will allow us to choose between Celsius and Fahrenheit for our display units. We'll then save that setting so that when we restart our app, the app will show the temperature data using either Fahrenheit or Celsius. So for this week's project, we're going to have several key things. We're going to create a new activity called Forecast Details Activity. We're going to pass clicked forecast data to Forecast Details Activity and display it on the screen. We will then create a menu with a single menu item, and that menu item will help us control the temperature display unit. When we click on that menu item, we're going to show an alert dialog. And then finally, we are going to update our UI formatting based on that selected setting. And that will be done using whatever setting is stored in Shared Preferences. So if I jump over to my emulator here and I open up the app, we can walk through what we'll be building this week. So at the end of week 3, you should have something that looks like this. You should be able to enter a zip code and then display that data in a scrolling list that has some nice touch feedback. This week, when you click on an item, we will open up into our details activity. If you then hit the back button, we'll go back to the main activity. Within the details activity, we're going to display the same weather data that was present on the list. Up here in the right-hand corner, we'll see that we have 3 dots indicating that we have a menu in the app bar. If we click that, we'll see we have added a single menu item with the label Display Units. When we click on that, we're going to show an alert dialog. That alert dialog is going to let us choose between Celsius and Fahrenheit for our display unit. In this case, I'm already showing in Celsius, so I will select Fahrenheit, and I'll see a message saying that that setting will take effect on app restart. So if I then restart my app and enter in a new zip code, we'll see all of this data is now properly showing in Fahrenheit. So that's what we will be working on this week and building up in our assignment. And it's also what we will be demonstrating later on in this lecture when we do the coding portion. So our first topic this week is using multiple activities, and specifically how to create and navigate to additional activities within our application. So how do we navigate to a new screen? Well, there's a few ways we can go about it. But to start, we're going to be using a new activity to navigate to a new screen. So to do that, we will create a new activity class. We will then declare that new activity in our Android manifest file. And then we will navigate to that new activity using an intent. So to create a new activity, we will replicate what we have done with the main activity in our existing application. So we could create a new activity.kt file and then define a new activity which extends from activity. And within that, we will then go on to overwrite things like onCreate, and we will implement the rest of our activity. So hopefully that should be fairly familiar to you. Next, we will need to declare our new activity in the manifest. So as we talked in the week 1 and 2 content, our manifest defines all of the components that the operating system is aware of. So before we can use our new activity, we need to declare it in the manifest. And that can be done in a single line if we want it to be. And we simply need to add the activity tag and then the name of the activity. And now the more interesting new bit. How do we navigate to this new activity using an intent? Well, in this code sample here, imagine we are navigating to a new activity from within a button click handler. So the first step is to create a new intent using a variable like this. So I've defined a intent variable called intent, and then I've created a new instance of the intent class. The constructor of the intent class takes in a context. So in this case, I've passed in this to reference main activity. And then you pass in the activity that you want to navigate to. So in this case, I've defined new activity, and you need to use a fully qualified class name here. So I've said new activity : class.java. This is just a special syntax you typically need to use only really when working with activities. So once we have our intent defined, we can navigate to that new activity by calling start activity. So what is an intent? Well, an intent is an object that helps communicate to the system that some action should be carried out. That action could be many different things. We could use an intent to start an activity, to send a message to a broadcast receiver, to send a tweet or an email, or to make a phone call. The makeup of an intent can include a variety of things, but typically it includes some specified action and associated data to go with that action. So here are a couple of examples of common actions. So the action view. And when using action view, you might pass in some type of data for this representing, let's say, a person in the local database. So in this case, the URI for action view, content://contacts/people1, is saying, give me the person, give me the contact in our phone with the ID of 1. And action view is going to say, I want to view that contact information. Similarly, if we pass in that same URI pointing to the person in our phone with contact ID 1, and we use action dial, we will tell the system we want to make a phone call to that person. Now, another common action could be action send, and this might be used in conjunction with extra data like an email or a subject to compose an intent that lets the system know that I want to send an email. So by combining actions, extra data, URIs, things like that, we can configure the action we want to take. Now there's two types of intents. The intents that we just saw, where we're specifying the action like view, dial, send, these are often what's known as implicit intents. But there's also an explicit intent, and we're going to talk about the difference there. Implicit intents describe an action, like action send for sending an email. They basically tell the system what you want to do, but then the operating system is free to choose what component to use to handle that. So that's why sometimes if you want to, let's say, send an email and you have multiple email clients on your phone, you might get an option to choose multiple clients to make that email. Similarly, if you want to send a text message, you might get multiple options like Facebook Messenger, WhatsApp, Google Messages, all of which know how to send and receive a text message. Now, on the opposite side, explicit intents, they explicitly describe a specific app component they want to interact with. So this is how we can explicitly tell the system we want to go from main activity to our new activity or to any other specific activity within our app. Now, implicit intents work off of intent filters, and we've already seen one example of an intent filter in this course. We've seen the intent filter for telling the operating system which activity in our app should launch when we click the app icon. So an intent filter is added to an activity or other app component tag within the manifest file. So we use an intent-filter tag, and within that, we can specify the action and the category that we want to respond to. So another example of an intent filter might be something like this. This could be an intent filter present in, say, an email app. So we might define an action of view some type of data or send to some type of data, and we might use a scheme here of mail to. So now someone could create an intent using send to, and as the extra data that's passed to that, it could include this mail to scheme. You can think of scheme kind of like a URL, but in this case, that URL will just point to an application component on your phone. So if we used this intent, we would likely get options on our phone such as Gmail or Outlook. Now, you can also pass specific data with intents, and we're going to do that this week. So in the case seen here, we're defining an intent to go to our new activity class. We're then calling intent.putExtra and assigning key value pair data to be included with that intent. So in this case, we're passing a key underscore ID and then a string value of student 616. So that's going to say we put the value student 616 at the key of ID. And this is essentially just going into a map so we can get that key value access. Similarly, we're passing the name Peter Parker with a key of key underscore name. And then at the very bottom, we call start activity again, and we pass in the intent. So those extras then, when the intent is handled by a new activity, those extras will be available to us. This is how in our assignment this week, we will pass the weather forecast data from main activity into our new forecast details activity so we can display it on the details screen. Now let's talk about how to display menus and dialogues within our activities. To display a menu, we'll make use of a menu resource. Within that menu resource, we can add individual menu items. Those items are what ultimately get displayed on the screen, like in the screenshot here. Display units is a menu item within a menu resource. Each menu item can be configured, and you can add text and icons to configure the look and feel and the message you're trying to convey with that menu item. And then finally, we can respond to menu item clicks to perform whatever action we want. So to create a menu resource, we're going to create a new file. Menu resources should live within the res/menu directory. So this is similar to res/layouts or res/drawable. Menu is its own resource type that lives within that res directory. And then the individual menus are XML files. So in this case, we've created settings_menu.xml. And the XML for that is fairly straightforward. We have a top level menu tag. Then we have the sort of XMLNS app and Android tags. Those are the same as you see at the top of layouts or the other XML resources. And then below that, we have this item tag. And within the item, we've defined a menu item ID, which we can use to reference the individual item when responding to clicks. And then we've defined the title as well. And if we wanted to do an icon, this would be the place to define the icon. Now to go ahead and display a menu within an activity, we can do that in the onCreateOptions menu method within our activity. Within that method, we get past the menu for the current screen. And we can use the menu to get a menu inflator and inflate our XML menu into the existing menu. So whatever items are in the menu will continue to be there, and whatever new items are present in settings menu will get added. And then we return true to let the system know, hey, yes, we want to show the menu. Now, once a user has interacted with the menu, it'll call this method on our activity called onOptionsItemSelected, and it passes in the menu item that was selected. So in that case, we can use the ID of the menu item to determine whether or not we need to handle that. So in our case, we are going to respond to the item click if a menu item with the ID of temp display setting was clicked. If that is not the item that was clicked, we will defer to the super.onOptionsItemSelected implementation. Now, how do we display a dialog on the screen? Well, we can create and show an AlertDialog, which is a specific implementation of a dialog. We can use AlertDialog.builder to customize how that dialog will look and how it should behave. We can update things like the title, the message, or the buttons in that dialog. And ultimately, we can respond to button clicks or even respond to the dialog being dismissed. We see in the screenshot here, we have created and shown a dialog, and it has a title of choose display units. We've customized the message to say choose which temperature unit to use for temperature display. And then we've customized a couple of the buttons to display Celsius or Fahrenheit, and we can respond to each of those accordingly. To show an alert dialog, like I mentioned before, we're going to create an alert dialog builder and then customize the properties on that builder. So in this case, I've created a variable called dialog builder, and I've assigned it the value of AlertDialog.builder, which is a new instance of that builder class. And then we can call methods on that like set title, set message, and then ultimately the last two there, we see set positive button and set neutral button. There's also a set negative button. So you can have up to 3 buttons in your dialog by default. Set positive button and set neutral button let you configure the label and then also what happens when it is clicked. And in the code demo a little bit later on, we're going to get into the more specific implementation of how to handle that. Finally, at the end, you need to make sure you show your dialog by explicitly calling show on the builder. Once show is called, it will actually then show up on the screen. Okay, now let's talk about saving data with shared preferences. So when we're building our apps, one of the key questions is how to store persistent data. Well, we have a few different options that immediately come to mind when thinking about storing persistent data. We could use a database. We could use files, or on Android, we have something specific for this use case called SharedPreferences. Databases, you might already be familiar with. Databases on Android are great for storing large, complex data sets, particularly if you have data that needs to support complex queries. Maybe you need to page in data because you have so much you can't load it all at once. You might want to respond to data updates in a reactive way. All of these are good reasons to use a database, like a SQLite database. Databases on Android are often the go-to option for caching network data so that your app works when it doesn't have a network connection. Now, we could also store data with files, and many apps that we use every day do this. We store images, videos, maps, books, audio, etc. We could also use files to simply write out our own custom data. So we could save settings data to these files. We could save and cache JSON responses from the network using files. So really, we have a lot of flexibility with files. But most of the time we're using files for media because we have other options for saving settings in large data sets in the form of databases and then shared preferences. So shared preferences is kind of the default solution on Android for saving simple data. And specifically, shared preferences work using key value pairs. So these are great for storing things like simple local user settings. So like in our demo this week, we're storing a display preference for whether to show Fahrenheit or Celsius. This is something that is not a lot of data. It's not something that needs to be persisted across devices necessarily, so we can store it locally using shared preferences. And ultimately, shared preferences actually are using files under the hood, but the API is nice and it abstracts that away from us. So as developers, all we really need to do is set and retrieve key value pairs. So here's an example of how we can work with shared preferences. So first off, we have to get an instance of the shared preferences class. So here I've defined a variable called preferences, and I've used a context and called get shared preferences. The first argument here, which is a string that says settings, that's the file name. So we can define different sets of preferences that live in different files, or we could use the same file for all of our preferences. That's kind of up to you as a developer. So in our case, we're just going to use all of our preferences in this single settings file. And then context mode private simply says that we shouldn't let other applications use these preferences. So it kind of keeps these settings hidden and private to our app. Once we have the preferences file, we can edit or retrieve data from those preferences. So in this case, to retrieve a value, in this case, to save a value, we call preferences.edit. Edit basically returns us back an object that allows us to change the values that are present. So in this case, we've called putString, and we pass in a key, this time key temp display, and then we've passed in a value. In this case, I'm passing in setting.name. And then once I've added all the data I want to add in this transaction, I call commit, or you could call apply. Either one will work. That commit call is what's going to actually save out all of those key value pairs to the local settings file. Now to retrieve a value, we can say preferences.getString and pass in our key, and it'll go into that file and look for whatever value is there. If it doesn't find that value, we can specify a default so that we can have some type of default returned to us and know that we have something to work off of. All right, so that's the lecture content for the high-level concepts this week. Now let's jump over to Android Studio and we'll walk through the implementation of this week's homework assignment. Okay, we are back here in Android Studio, and we're going to get working on adding our new activity this week. Now, before we get started, I'm going to come over to the left-hand side of the screen and look at the project pane here. Once again, I'm in Android view, but the same applies if you are in project view. So here I've navigated to the directory where all of our source code currently lives. And all of this code has currently been living in the same source directory. As we go forward this week, though, and further on in the course, we'll want to start thinking about how we can organize our code so that it's easier to navigate and manage as we continue adding to it. One way we can do this is by organizing things in packages. A package is simply a directory on your computer that stores source code. So in this case, I'm going to come here to the directory all the code is currently in, com.goobar.io 8340. And I am going to right click on that and select New, and then select Package. Now this will prompt me to create a new name for this package. And I'm just going to type details. So the full package name will be com.goobar.io 8340.details. And of course, yours will be customized based on whatever package name you have specified. The key thing here is to make sure that the last bit that we are adding right now is details. So once I've updated that package name, I'll hit enter. And you'll see here that it has created a new directory called details. Next up, we're going to create our new activity. To do this, we will right click on details, select new, then scroll all the way down to the bottom here where it says activity. And then in this little submenu, we will select an empty activity. Once I click empty activity, this new dialog pops up to create a new Android activity. So where it says activity name, we want to update this, and we're going to name our new activity forecast details activity. And we want to make sure the little checkbox is selected here that says generate layout file, because we do want and need a new layout XML file for this new activity. By default, it should pre-populate the layout name. You can do whatever you want here. Mine is going to be called activity_forecast_details. This is a pretty common naming convention for the layouts that associate with an activity. And then go ahead and leave the package name and the source language the default values, and we'll select finish. And then if you get prompted to add the files to Git, go ahead and select add. And so now this should have created a new details activity for us. And in fact, it likely has even automatically opened that details activity for us, as in the case here in my screen. Now, one small oddity of Android Studio to point out is, for some reason right now, it seems to not be automatically importing the resources for you when you generate your new activity. So here, even though I've just created this activity, I already have this error, which is frustrating. However, we can easily overcome this by putting our cursor over that R statement there and hitting Alt-Enter to automatically add the import. And just to point it out, the import here at the top is import and then the package name and then just .r at the end. So that's the activity. That's the first thing that was created for us, is this activity class. However, there's two other things that were done for us when we created that activity using Android Studio. The first is that it created this new layout for us. And so I'm going to select Command and then click on this layout file. If you're on Windows, it'll be a control click. And I'm going to open up into activity_forecast_details.xml. And so right now, this is the layout file for this new activity. And you see here in design view, it's completely blank at the moment, which is no surprise since we selected the empty activity template. This is what we wanted. Now, the last thing that was done for us when we created that new activity was the manifest was updated. So if we navigate over to our manifests, so in Android view, that should be in the manifests directory at the top of the window there. If you're in project view, the manifest should live under app/source/main. In either case, once you've opened Android manifest.xml, you should have a new activity element in that manifest. Here, it's been organized as a single line of code, and so I'm just going to clean this up a little bit to make it easier to read. But ultimately, we have defined in our manifest a new activity, and we've indicated that the name of the activity is .details.forecastDetailsActivity. So this name, it requires us to specify the fully qualified package name. So if this had been in the top level package, like our main activity is, we wouldn't need any preceding package name here. But because this is in details, we add .details.forecastDetailsActivity. So that just lets the system know exactly where in our source code to find this activity class. So now, if we were to run this activity, we would end up seeing the same code that we saw at the end of week 3. But if we wanted to update this to launch our new activity, we could come down here to the main activity tag, and we could select this intent filter. Now, we mentioned previously that this intent filter is what indicates to the system that main activity should be what launches when we start our app. However, if we move that from main activity to forecast details activity, now when we run our app, it should run forecast details activity instead. And we will run this in our emulator. There we go. We've seen now that that activity has relaunched, and we see before we had the list, and as soon as it relaunched, we now just see this blank empty screen, which is our forecast detail activity at the moment. So this is perfect. This is exactly what we would expect. So we're going to come back over now to Android Studio, and we're just going to revert that change and make the main activity the launcher activity once again. Now what we want to do is be able to actually launch forecast details activity when we click on one of our list items in the home screen. So to do that, we're going to go back over to main activity. And what we want to do is launch forecast details activity when we click one of our list items. So the handling of our list item clicks is down here when we are creating our daily forecast adapter. And currently we are displaying a toast message. So we are going to remove the displaying of that toast message. And we're going to replace this with creating a new intent and then using that intent to start forecast details activity. Now to do that, first we will create an intent variable. So we'll start off by typing val forecast details intent. So in this case, I'm including forecast details in the name of the variable to indicate that this will be an intent to launch forecast details activity. Now to create an intent, I type intent and then an open and close parentheses. Now I will need to import this. So again, I'll hit Alt-Enter and that'll automatically add the import and fix the compile error. So now I am invoking the intent constructor. To make this an explicit intent, which remember we talked about means that we're going to explicitly tell it what component to launch, I need to do two things. First, I need to pass in a context. So I'll type this to pass in the main activity context. Next, I need to tell it what activity I want to open. So to do that, I'll start typing forecast details activity, : and then class.java. And I know that's kind of a weird syntax. There's really a syntax that is only used in this case of creating intents generally. Essentially, that is pointing to the actual generated Java class for this at the low level for the compiler. So in doing this, we now have an intent that when launched should tell the system that we want to launch the forecast details activity. To actually launch it, we can type start activity and pass in our forecast details intent. Start activity is a method on an activity that lets you go from one activity to another. So now, if we rerun this once again, we should be able to switch over to our new forecast details activity when we select an item. So if I type in a zip code and I select a list item, we're now taken over into forecast details activity. So we've now successfully navigated from one activity to another one for the first time. Now let's go back to Android Studio and let's make our forecast details activity layout a little bit interesting. So we'll go over to forecast details activity and we'll see here that currently we aren't doing anything. We're not customizing the UI in any way. It's just blank. So the first thing we want to do is update the name of this activity so that in our app bar, we have more of an indication of what's going on that screen. To do that, we're going to go to the left-hand screen over here into the Android or project window again. We're going to go to strings, and then we're going to create a new string resource called forecast details. So I'll type angle bracket string, and for the name, I'll type forecast details. So that's the resource name. And now for the actual string to display, we're going to type forecast details. Now we want to use this to change that activity title. So if I go back to forecast details activity, I'm going to hit enter a couple times to give me some space below the set content view call. And I'm going to type set title. Set title is a method on an activity that lets you do just what it suggests. It lets you set the title for that activity. And then by default, that title will get used in the app bar of applicable themes. So if I pass in r.string.forecastDetails and then rerun this, we'll be able to see that new forecast details title in the app bar here of our emulator. So if I go back over to Android Studio now, we're going to customize the layout of our activity forecast details XML file. So I've come over here into the XML, and I want to make sure I'm in the design view because we're going to do this visually. So the first thing we're going to do is come to the palette view here, click on the text option. You could also use the comment option here, either way, but we're going to grab a text view element and we're going to drag that into our layout here. And I'm gonna increase the size of this a little bit, make it easier to see. So I've just dragged a text view into our layout editor here. And the next thing I want to do is just kind of clean up some of the common attributes here. So by default, I don't want it to say anything because we're going to specify what it should say later. So if I clear out the text property here and hit enter, we'll see that it takes away the text. So this is a good thing but it also is a challenge for us because now we don't know what this looks like. Well, there's a useful tool that we can leverage here to solve this problem, and it's actually called the tools text attribute. So if I go into this common attributes drop down again here, and I see the text attribute that we just edited, and then there's this other text attribute that has a wrench next to it. This is the tools attribute. And if I type 75.4 degrees and hit enter, we'll see now magically our text view has text again, even though the Android text attribute's not selected. I'm going to come over to XML just to illustrate again what this actually is looking like here. So we see this attribute right here that says tools text 75.4 degrees. This is different than the Android text attribute. Basically, some attributes like text have this tools attribute with it that lets you set how to preview that in the editor, but it won't actually be applied at runtime. It's just a useful way to help build your UI without having to remove that text at runtime in your code. So here again, we have our temperature text view, and we've set our tools text to some temperature preview. The next thing I want to do is make sure I have the text view selected, and I'm going to change the ID property to temp text. And we'll use that ID later when we reference this view to set the temperature ID. And now I want to make sure that this is properly constrained. So I'm going to grab the little arrow, constrain it to the left-hand side of the parent. Then I will also constrain it to the right-hand side of the parent and the top. And so by default, this is going to put it at the very top, and it's going to center it. Now I don't really want it centered. I want it to actually hug the left-hand side of the screen. So I've come here into the layout tab of the attributes panel, and down here towards the bottom of this little rectangle, there's this slider that indicates horizontal bias when you hover over it. This horizontal bias is basically there because we have constrained ourselves to the left and right hand side of the parent. The bias lets us indicate whether we want to prefer one side or the other. Right now it defaults to 50, so we're right in the middle. However, if I drag this over to the left, we'll see that our view is going to drag over to the left as well. So that is what we want, because we want it to start from the upper left there. However, there's one other small problem here, which is that it's hugging the top and left directly. It's right up against the edge. And generally in good design, but specifically good like Android material design, we do not want to have our elements directly to the edge of the screen. What we want to do here now is add some margin. And we can add margin in a couple ways, but the easiest is to come over here again into the little layout panel here. And where we have this rectangle again, we see these little drop downs that all say 0. That 0 value right now is indicating that we have 0 margin between the edges of this element and the edges that it is constrained to. If I come to this little left-hand drop down here, and I select 16, we'll see that it pushes the text view away from the left edge by 16 dp. Now we can do the same to the top here. I'll select 16, and you see now it's pushed it down. And then I'm going to add 16 to the right as well, although we're not going to really see any visual indicator of that at the moment. So now our text view has some spacing between it and the edge of the screen. You could also set your margin in the XML. So if I come back to the XML view here, and I look at my text view, I see several attributes all mentioning margin. We see layout margin start, layout margin top, layout margin end. We could also set these all at once by just typing layout margin 16 dp. The layout margin will apply that same margin to each of the specific edges. If I come back over here now into my view or my design view, we'll see that I still have the layout margin here. Although you don't see the individual values anymore here in the layout panel. Although you do still see that down here we have some margin along those constraints. So there's a little bit of disconnect there. What I would recommend is to just go with the design view on this one and leave the margin applied to the individual elements because it's more explicit and the tooling works better with it. You see, as soon as I added back those individual elements, I see my margin values back here in the visual editor again. So now that we have that text view sort of updated, we're going to walk through the same process again. We're going to add another text view by dragging it over. And we're going to, once again, clear the text property by coming down into the Common Attributes drop-down panel here. I'm going to clear the text property, and I'm going to update the Tools text property to say partly cloudy. So now I have a new text view that is going to contain the description of our current forecast item. Now, how do I want to position this on the screen? Well, I want this to align to the left-hand side of our other text view and be below it. So I will select the partly cloudy text view here, and I'm going to grab the little arrow on the left-hand side here and constrain it to the arrow on the left-hand side of the temperature text view. And then I'm going to grab the top circle here and drag that up to the bottom circle of the temperature text view. And so now those are constrained together. If I were to move around the temperature text view, we'll see the partly cloudy one would move with it. And just to kind of review what that looks like in the XML, we see here, this is our new text view, and we've said constrain start to start of temperature text, constrain top to bottom of temperature text. So if we go back over into the design view, we have now constrained this. We want to make sure that we apply our ID attribute. So the ID of this one is going to be description text, because it'll hold our forecast description. Now, this layout here, it's fine, it shows us the data, but it's not very interesting to look at. So let's change that before we move on. Let's go ahead and select the temperature text. And then we are going to scroll down to the Common Attributes panel here over on the right-hand side. And where it says Text Appearance, we're going to click this drop-down, and we're going to scroll down to the Display 4 option. And so you see that immediately makes it really, really big. In fact, possibly a little too big. So let's change and select Display 3 instead. And that's looking a little bit better to me right now. It's not quite so overwhelming. So next then, I'm going to click on the description text, do the same thing, come over to the Common Attributes dropdown in this Attributes panel here, go to the Text Appearance attribute, select the dropdown, and I'm going to select Display 1. And so again, it's going to automatically apply that text appearance style to that text view. If we were to look at this in the XML, this is what it would look like. Each of our text views now has this Android : text appearance attribute. And the style is referenced using @style textappearance.appcompat.display1 or display3. So those are predefined styles available to us from the appcompat library that was automatically added to our project when we first created it in Android Studio. Using these text appearance styles is a really nice way of leveraging sort of the default material design guidelines around text and really make your app look nicer when you are building your UI. So now that we have our nicer looking and non-empty layout file defined here, let's redeploy this to our emulator and check it out on the screen. So I'll go ahead and click redeploy, and we'll switch over to the emulator. I will now enter my fake zip code, click on an item, and we are here in forecast details screen, but it's blank. Why is that? It's not blank in the design view, but it's blank on the emulator. Well, this goes back to that tools text attribute we talked about. So in Android Studio, again, we are seeing text on the screen because the tools attributes are defined, but the actual text attribute, which is the one that gets shown on the screen at runtime, that one is still empty. So to fix that, we need to go into our forecast details activity, and we need to actually set some values into those views. Before we can do that though, we need to reference our views like we've been doing in our other activity. So to start, we'll type val temp text equals find view by ID. And for the template, we'll type text view, since that's the type of element we want to work with. When prompted to add the import, we'll go ahead and hit Alt Enter to automatically add the import up at the top. And now in the find view by ID parameter list, we will pass in r.id.tempText. So that gives us a reference to that temperature text view. And now we'll do the description view. Val description text equals find view by ID. We'll specify text view, and we'll pass in r.id.description text. So now we have references to both views. Let's just put in some placeholder text so we can see what this looks like on the screen. So we'll say tempText.text equals 81.2 degrees, and description text.text equals mostly sunny. So now let's redeploy this one more time. And I will enter my zip code. I will click an item. And now, finally, when we open up forecast details, we see some actual interesting information on the screen. It's not just a blank activity anymore. So that has been the first step in this process. We created our activity and we've updated the UI to be ready to display the forecast information. So now our next step will be to actually pass in the needed information from whatever item we clicked on. Now that we have successfully linked our list items to launching forecast activity, the next step is to actually pass the clicked item data over to that activity so we display the same information that we clicked on. So how do we actually go about doing that? We need to somehow pass that clicked forecast item to the new activity. So let's start by going over to main activity. We're going to kind of scroll down to the bottom. We're going to create a private method called show forecast details. And this is going to consolidate all the information we need to show that new activity with the required data. So to do that, we're first going to grab the intent creation and the call to start activity. And we're going to just move those into our new method down at the bottom. So it's just a simple copy and paste. And now here in our adapter click handler, we're going to replace those with the call to show forecast details. So now still, once it's clicked, we're going to come down here and it'll call show forecast details. So now we have our intent. We want to pass the temperature and the description along with this intent so that when forecast details activity is opened, we can display that on the screen. So to do that, we can use intent extras. To add an intent extra, we first reference the intent variable and we type dot and then put extra. And you see here that we have a lot of overloaded put extra methods here. So all of these work off of key value pairs. So we could use a string always for the key value, but then we could use things like integers, booleans, floats, strings. We can pass in a number of different data types as the value. So for us, in our first case here, we're going to pass in key underscore temp as the key. So this will be the temperature value. And now we need the actual forecast data. We need to know what it is. So we need to pass that from the adapter click listener to this method. To add a parameter to a method, we'll click into the parentheses there of the method. And we're going to first type the parameter name. So in this case, that will be just forecast. Then we'll type a colon, and then we need to specify the type of that parameter, which in this case is daily forecast. So remember, that's our model that we defined last week. So now we are passing in a forecast item. So in our put extra call here, we can type forecast dot temp. And now for the description, again, forecast details intent dot put extra. This time we'll use key underscore description for our key. And then we'll pass in forecast dot description for the value. Now, the only thing we need left to do is to pass that forecast item in from our click adapter. So we could do that by either typing just it, or we could be a little bit more explicit and we could come within our Lambda and we could rename that it receiver parameter to forecast. So it's more clear that this is a forecast item. And now we can type forecast here and pass that in. So now what's happening here is when you click on an adapter, we're being returned the specific forecast item that you clicked on. We're then passing that to the show forecast details method. And here we're creating a new intent. We're putting that forecast information into the intent as extras and then starting the activity. So now if we go to forecast details activity, how do we actually get those extra values out of the intent and into our text views? So if we come here into onCreate and we go a couple lines down below where we get the reference to our views, we can get access to that intent extra data. So to start, let's just show how you could use that to get the temperature. So we'll type val temp equals intent dot get float extra key temp, and we'll pass in 0 as a default. So this is the full line. Let's break this down a little bit. So first off, we create a temperature variable. Hopefully no surprises there. The next thing though is referencing intent. So forecast details activity have an intent. Any activity has an intent that was used to launch it. And we can reference that in Kotlin by simply typing intent. You could also replace this by typing get intent, but typing just simply intent is the is the preferred idiomatic way of doing it in Kotlin. This is what's known as property access syntax. Instead of using the getter called getIntent, we can just reference intent directly. So it's a little simpler. So we type intent, and then on an intent, just like we could put extras into it, we can get extras out of it. And so for us, our temperature value is a float. So we use the getFloatExtra method, and then we use the same key that we put the data in with to get it out. And then we pass in a default value just to handle that error case in case for some reason that property wasn't put in. So with this, we can get that temperature data and set it into our text view. So let's actually update that now. So down here where we had our temp text, we are going to create a new format string using Kotlin string templates. So to do that, I'm going to type $, and then open and close curly braces. Now within that, we will define the code that's going to get the temperature value for us. But to just complete the formatting, we're going to add the little degrees sign so that this will read as, whatever float value degrees. Now we're going to copy that code for getting the float extra and place it down inside that open and close curly braces. So this is going to take that float value, convert it into a string, and add the temperature value to that. Now let's do the same thing and grab the description. So we'll say description text.text equals intent got get string extra key description. And now we can redeploy this. So we will enter a zip code. We'll see here we're going to click on this item that says 74.87. And we see over in our new forecast details screen, we see 74.86745. So this is the same item, although the rounding is a little bit different. So let's go ahead and update how this looks. So we'll go back into Android Studio, and to illustrate one other point that you might run into, we're going to go back to our layout. So let's set this to display 4, where the text was much, much larger, and redeploy this and see what this looks like. So again, zip code. So now with this really large text, having those extra decimal places has moved this onto a second line. Now, if you are on a really big screen, this might not be an issue, but this emulator of mine is simulating a much smaller screen, and so I'm running into multiple lines. However, I don't want this in my UI. So how could I go about fixing this? This is a very common problem in building UI for mobile devices. So to fix this, we have a few options. We go over to Android Studio, and we're going to go into the XML view for this layout. And on the text view attribute, we are going to add a new line here, and we're going to use this property called max lines and pass in a value of 1. And then we're going to use another attribute called ellipse size and pass in a value of end. So what this should do for us is say only make this line one line of text, and if the text can't fit in that single line, then add the 3 little dots for the ellipses at the end of it. So if we come back to the design view here, nothing has really changed. However, you could try and verify what this is going to look like by changing the device preview for this layout. So right here where for me it says pixel, I could scroll down to the bottom and you could customize or use these different device skins to see what it might look like on different device sizes. So for me, I'm going to use this custom one I have at the bottom that is for a smaller device. And we see here that it shows that the text is definitely larger, but because it's only 1 decimal place, I don't have a problem. To simulate the problem we're seeing on the real device, I could update the text to say something like 75.43212 and hit enter. And we'll see now that this has not wrapped onto a second line. It is thankfully still on just the single line here. However, it's not really honoring the ellipse size that we added. You also, and it might be hard to see here, but it's no longer respecting the margin that we had defined either. This is because of the way we have set up our constraints. So if we go to our layout tab here, we'll see that the width by default is set to wrap content. And many times wrap content is perfectly fine for working with text views, even within a constraint layout. However, if you have some text that you really do want to constrain to like a single line or a couple lines, and you want to make sure the width is roughly a static size, as in our case here, instead of using wrap content, what you want to do is use 0dp. 0dp will make sure that instead of scaling the text view to wrap the content no matter what the constraints are, it'll honor the constraints and limit the size. So as soon as I've done that now here in my preview, it has adjusted that to honor the constraint and show that margin on the right hand side. So if we now run this on our device, we should be able to see some of these effects taking place. So once again, enter a zip code, click on this, and now we see our text view is no longer wrapping, and it's adding the 3 dots of the ellipses at the end to indicate, yes, there's some additional temperature data here, but we're not going to wrap onto the second line. So that's fine. That's one way we could solve this. However, we already saw last week that we can format the text to have just 2 decimal places if we want. That's what we're doing on the list value here. So let's think about how we might replicate that formatting and use it on our details activity as well. So go back over to Android Studio, and the first thing we should think about is, well, how are we doing this before? Well, for last week's assignment, we were formatting that data in our view holder. And we were using this line of code here. We were using the string.format method. So we're going to copy that method, and then we're going to go into our project view over here on the left-hand side of the screen, and we're going to right-click the top-level package, select New, Kotlin file, and I'm going to create a new file called forecast utils and hit enter. In this utils file, we're going to create a new function that will define this formatting for us, and then we'll be able to reuse that function in multiple places. So I'll create a function called fun format temp for display, and it's going to take a single parameter, which will be the temp value as a float, and then this is going to return a string. So we'll add colon string as our return type, and now within the function body we will type return, and we will paste in that line of code that we took from the view holder. So we'll type string.format, we'll pass in our formatting string for 2 decimal places, and then we just need to update the temperature reference there. So now we have this reusable bit of code for formatting the temperature data. So if we go back over to the view holder here in our adapter class, we could make use of that by replacing the formatting function with a call to format temp for display, and we'll pass in daily forecast.temp. And so now we want to basically do that same thing, but in our forecast details activity. So here we'll create a new variable called temp, and we will get the temperature value out of the intent like we did before. So using intent.getFloatExtra. And then we can assign the value to temp text as format temp for display, and we'll pass in that temp value. So now if we rerun this, now we'll see that even in forecast details activity, we only have 2 decimal places. So this is nice. Now we're being consistent. However, one thing that's missing is we don't have the little degrees symbol after the value. Well, we can now update this for both screens in a single place since we consolidated that functionality into a single function. So if we go back to Android Studio, we go to Forecast Utils, I can come into my formatting function here and just add the little temperature symbol. And if I rerun this, now when I display the list items, we'll see that they all have the little degree sign. And now when I click in, it also has the degree sign. So consolidating that common logic into a single helper method is a huge win for us, because now anywhere we need to format this temperature data, we can do it in a single spot, which just makes it easier to maintain moving forward. Now that we are displaying the formatted temperature correctly, we want to dive into how to display a settings menu and how to display an alert dialog, and how we can use those working together to build some simple settings into our app. So the first thing that we want to do is create a menu resource directory. To do that, I want to come over to the res directory in my project. Once I've selected the res directory, I'm going to right click, go to New, Android Resource Directory. And where it says resource type, I'm going to select menu, and it should automatically then change the directory name to menu as well. And I'm going to go ahead and hit OK. So you see now underneath the res directory, along with drawable and layout, bitmap and values, we now have a menu directory. So now right click on that menu directory, select New, Menu Resource File. Once I've selected Menu Resource File, we're going to give it the name settingsmenu.xml. And I'm going to go ahead and click OK and add that file to Git. So this has now pulled open this design editor for the menu, and it works very similarly to how the layout design editor works. I have a palette here on the left side of the types of items that we can add to our menu. So I'm going to start, and I'm just going to grab the generic menu item, and I'm going to drag this onto the design editor here. And oops, it accidentally dragged 2 over, which we don't want. So there we go, just a single item over. And now if I click that item, I can update properties on it just like I can with a layout item. So I'm going to set this ID to temp display setting. And again, that's over in the common attributes panel on the right hand side. And I'm going to set the title to display units. Now, ideally, this would be done using a string resource. However, I'm going to leave that as an exercise to you in the homework to implement this using string resource. So for now, I'm just going to define this using a hard-coded string. Now, we're going to go open to our forecast details activity, and we want to inflate this menu when the activity is created. We want to be able to see that menu. To do that, we're going to come down and we're going to make use of a method called onCreateOptionsMenu. So if you start typing onCreateOptionsMenu, it should auto-populate that for you eventually. Within onCreateOptionsMenu, we're going to do a couple of things. First is we're going to get a reference to the menu inflator. And we can do this by typing val inflator : menu inflator equals menu inflator. So we can get direct access to the menu inflator from an activity. And the variable here is just helping us leverage that. Then we can type inflator.inflate. This is very similar to working with layouts, and we'll pass in r.menu.settings_menu, and then we will pass in the menu that we are getting as a parameter in createOptionsMenu. And then we will return true. Returning true here simply indicates like, yes, we've handled this. We want to show the menu. So now if we redeploy this, we should see our menu when we open up the details activity. And so see, we do. In the app bar, we now have the 3 dots, which on Android indicate that there's a menu. If I click that, we see the display units menu item that we had added. And if I click that, currently nothing happens. So let's fix that. We'll go back over to Android Studio. And to handle clicks on menu items, we want to use a method called onOptionsItemSelected. So the activity methods refer to options menu and options item. Those are essentially the items or the quote unquote options within the menu. So within onOptionsItemSelected, we're passed in a menu item, which is whatever item was clicked. So to handle item selection, we can basically check the ID that was clicked and respond accordingly. So to do that, I'm going to start off by typing return when item.itemID. So what this is saying is it's going to return the value of this when expression. This is very similar to a switch statement in Java. We've passed in item ID, so this is going to let us compare different values of the item ID. So the first case that we want to concern ourselves with is r.id.temp display setting. So now we have defined a case, which is if the ID is temp display setting, we will do something. Else, and in the else case, we're going to just return super.onOptionsItemSelected. So now, in the case where the user has selected our display setting option, for now, we're just going to show a toast. So we'll type toast.makeText this clicked menu item toast.lengthShort.show. And then we need to make sure that we return true to indicate that we handled the click. So if we run this now, we should be able to see our toast value when we click that menu item. And there we go. So click the menu item, see a toast. So that's menus in a nutshell. We could use these for numerous things. Maybe you want to control whether or not you have dark mode available in your app, a display setting, any type of setting. A menu option could be a way to get the users to there. It's not the only way, but it is one way, and it certainly works. So now the next step in building up our kind of temperature display settings is to show a dialog that will let the user choose between Fahrenheit or Celsius. So to start with that, we're going to create a new private method on the forecast details activity. We're going to say private fun, and we're going to call it show temp display setting dialog. And now up here, instead of showing a toast, we're going to call show temp display setting dialog. So now we'll come down into this method, and we're going to use this method to display an AlertDialog. Now, an AlertDialog is a simple modal. It's a little tiny window that pops up over the top of your other content and lets the user select an option. You maybe enter some text, do some type of little one-off thing. So they're meant to be very kind of transient in nature, but they're a nice way to get contextual focus from the user. Now we can create an AlertDialog by using what is called an AlertDialog builder. A builder lets us kind of customize the dialog without having to know how it actually is built under the hood. So to start, we will get a reference to the builder by typing val dialog builder equals AlertDialog.builder, and we'll pass in a context. When you go to import the AlertDialog, you might have two options. You might see Android.app or AndroidX.app.compat.app. It's a good idea to go with the Android X version. So I'll select that and hit enter. Now we have this AlertDialog builder, and now we can start to customize properties on this. So we could say dialog builder.set title for start. And for our title, we might say something like choose display units. Now that's not all the customization we're going to do, but let's stop there for a second and just see what this looks like. So to actually show our dialog, we need to say dialog builder.show. And what that will do is actually create an instance of the dialog and call show on it for us. So if I run this and switch over to the emulator, I will enter my zip code. I will open up my menu item, and there we go. We see a simple and not very attractive dialog on the screen. So now let's continue building out this dialog so that it is more useful and appealing. So up here where we have our dialog builder, there's one small change we can make. So here we've called dialog builder.setTitle. And let's say we wanted to next do dialog builder.setMessage, and maybe our message is choose which temperature unit to use for temperature display. So we could continue customizing this dialog by referencing dialog builder every time. However, Dialog Builder has what is known as a fluent interface to it, basically meaning that we don't have to reference Dialog Builder every time. We could call set title directly and set message directly. And the way that this works is that AlertDialog Builder here, this constructor essentially returns an instance of the builder. And so then I can call setTitle on that like I would any other object. But setTitle also returns the builder. So then I can call setMessage. So it lets you chain these together, which is why they call it a fluent API. It just makes it very easy and natural to write. So now that I have defined the title and the message, we're going to define what the positive button is going to look like. So to do that, I'll type set positive button, and I'm going to pass in F degrees to represent Fahrenheit. And then I am going to pass in a click listener for this. And to do that, we're going to do open and close parentheses. And then we're going to type underscore, comma, underscore, because the click handler for this typically takes 2 parameters. However, in our case, we're not going to use them. So we'll do underscore, comma, underscore. Then we'll type our lambda arrow here, which is just a dash and then the angle bracket. And now I can define what to do when we click the positive button, which for now is just going to be a toast. So we'll say toast.makeText this, comma, show using Fahrenheit, comma, toast.lengthShort, show. So that takes care of our positive button. Now let's do the neutral button. We could do negative button as well, but I'm just going to use the neutral button for now. So we'll say set neutral button. So the message for this will be Celsius degrees. Now, if we didn't want to use a lambda for defining the click listener like we did for the previous one, we could demonstrate what it looks like to do the full version, just to see how we're kind of saving ourselves some code. So this time we could type object colon dialog interface dot on click listener, and then we need to implement the on click method. So this is what we are essentially simplifying in the set positive version. So the set positive button, the set neutral button, they take in an instance of dialog interface.onClickListener. However, in Kotlin, we can simplify that using lambdas, which is why in the positive case, we just have the open and curly brace passed outside of the parentheses. So basically everything happening within these parentheses on set positive button is taking the place of all of this. So it's taking the place of the object colon dialog interface on click listener and taking the place of override fun on click. So if you want to use either one, that's perfectly fine. I'm going to go with the simplified version just because I like to have the less code there. And so in the case of the Celsius version, we're going to basically just show the same temporary message here for now. And I'm going to go ahead and rerun this once again just to check in and make sure everything is working as we expect. So I'll click my menu, and now we see our title, we see our message, and we see the Celsius and Fahrenheit option. So if I click that again, and this time let's say I click Celsius, I see the appropriate toast message being printed out to the screen. So let's go back over to Android Studio and kind of finish up this implementation. So one other thing that we want to do before we finish is to add a dismiss listener. A dismiss listener will let us do something whenever the dialog is closed. So in our case, we're going to tell the user that their display setting will take effect after they restart the app. So we're going to add the dismiss listener by typing .set on dismiss listener. And we're just going to add a toast once again. So toast.makeText, pass in this. Setting will take effect on app restart. Toast.length length short dot show. Show. So let's rerun it one more time just to check our work here. Select display unit, select Celsius. So first we see show using Celsius. Setting will take effect on app restart. So there, we're getting both the output messages that we would expect. So now that we have this user interface ready to go, we need to actually define the management of this temperature display setting. And so to do that, we're going to create a new class called Temp Display Setting Manager. So to do that, we're going to come over here again to our project window. We're going to right click on our package and select new Kotlin file or class. And we're going to just name this Temp Display Setting Manager. And so that has created a new Kotlin file for us. So within that, we're going to create a new class to match the name of the file. So class Temp Display Setting Manager. Now above that, we're going to create a new enum class called Temp Display Setting. And we're going to use this enum class to explicitly enumerate the different temperature settings available to us. So in our case, that will be Fahrenheit and Celsius. And so now we'll be able to use those values elsewhere to explicitly state whether we're using Fahrenheit or Celsius. So now we need to go ahead and implement this, this temp display manager. And temperature display manager is going to reference shared preferences to save the temperature display setting value. So to do that, we're going to need to pass in a context to this class because we need a context to get reference to shared preferences. So I will take in a context parameter, and then within my class body, I'm going to use that context parameter to get a reference to the shared preferences object. And I'll do that by creating a private property called preferences equals context.getSharedPreferences. When I pass in the name of the shared preferences file I want to use, I just want to call this file settings. And we're going to open shared preferences into mode private because we want these to be private to our application. So like we saw earlier in the lecture, this call to get shared preferences is essentially opening up a file on the disk or creating it if it doesn't exist. And it's going to allow us to write out key value pairs of data to this file using a very simple API. And this is kind of the default simple way of storing small bits of data that you want to persist across application restarts. So now that we have our reference to the settings, the next thing we're going to do is create a public method called updateSetting. And we're going to pass in a temp display setting value. So we'll call that parameter setting, and it will be of type temp display setting. So this is going to let us call updateSetting, and we'll pass in either Fahrenheit or Celsius to indicate how we want the temperature to be displayed. So when the user calls updateSetting, we're going to want to update our preferences with that setting value. To do that, we'll type preferences.edit. Edit will start us into an edit mode that we can use to edit the preferences. Once we're in that edit mode, we can type put, and you'll see that we have a number of different types of data that we can store with shared preferences. So in our case, we're going to type put string, and we're going to use a key of key temp display. And we're going to pass in setting, which again is either going to be Fahrenheit or Celsius. And we're going to pass in the name property. So any enums in Kotlin have a name property that will match how the class name is defined. So we can pass in setting.name. And then the last thing here is we need to call either commit or apply. Commit will immediately write our changes to the disk. Apply will do it in the background. However, in this case, because it's a one-off thing and it's a small piece of data, commit should be fine. So now that we have given the user a way to update the setting, we need a way to retrieve the setting. So to do that, we'll add a method called getTempDisplaySetting. And it's going to return an instance of temp display setting. So this will either return Fahrenheit or Celsius. Now, to actually get that value, we're going to create a variable called settingValue equals preferences dot get string. And we're going to pass in the same key we used before, key temp display. And so now it's going to ask us to specify a default value. So for us, our default value is going to be temp display setting dot Fahrenheit dot name, because we need the string value as opposed to the actual enum value. And so now what we want to do is call return temp display setting dot value of setting value. Now, what does this do? Well, temp display setting dot value of is making use of the value of method of an enum, which basically says I can pass in a string to value of, and if that string matches the name of one of the enum types, in our case Fahrenheit or Celsius, then it will basically return you back the instance of that. So if I pass in the string Fahrenheit, I'll get back an instance of Fahrenheit temp display setting. So this is what is basically mapping the string version of the name of the setting to the actual static enum type. Now we have an issue here, basically saying required string found string question mark. So what does this mean? We haven't seen this question mark syntax. This gets into nullability in Kotlin. As a quick demonstration here, if I type val foo colon string equals some string, this is what's known as a non-nullable type. If I tried to assign the value of null here, like we might be used to in Java, this gives me an error. And basically the error says null cannot be a value of a non-null type. If I wanted to use null here, I could add the question mark after the type. So a question mark indicates that it is a nullable version of that type. So in this case, a nullable string. So down below here, this error on setting value is saying I expected a non-null version, but I found a value that might possibly be null. So basically what it's saying is that key temp display could actually return null, even though we have this default here. So the way we can handle that is by going to the end of the line, typing question mark, colon, and then basically just replicating our default value one more time. And I know that looks a little bit weird. Essentially what that's saying is that if everything on the left-hand side of the question mark evaluates to null, then instead of returning null, it's going to return what's on the right-hand side. This question mark colon is actually referred to as the Elvis operator. I'm not sure why. Always seemed like an odd name to me, but basically it lets you substitute out a null for some other default value. So as soon as I do that, settings value no longer has an error here. So now we know for sure that when we call get temp display setting, we're either going to get back Fahrenheit or we're going to get back Celsius. So now we can actually make use of these settings. If we go to our forecast details activity, we can update what happens when we click the button. Before we even do that though, we need to get a reference to a temp display setting manager. So we're going to come up to the top of forecast details activity, and we're going to create a new private late init var property called temp display settings manager. Now this is a different syntax as well that we haven't seen before. Late init var means this is a variable that at some point will be assigned a value, but it isn't going to be assigned one right now. So there's a contract here by saying before you actually use this, it needs to be assigned, otherwise your app will crash. But it leaves you free to assign it later. And the reason this is done a lot of times in Android is because a lot of things need a context, and your context isn't value until onCreate has been called. So for us in onCreate, we can initialize temp display settings manager in onCreate by invoking the constructor and passing in this. So now any point after this, we can safely use temp display manager. So now if I come down here to our alert dialog, when I click the positive button, I can call temp display setting manager dot update setting, and I can pass in temp display setting Fahrenheit. And now in the neutral Celsius case, I'll do the same, but I'll pass in Celsius instead. So now we have a way of actually retrieving and saving the temperature setting of Fahrenheit or Celsius. And in response to our dialog button click, we're actually updating that value accordingly. So now we need to actually make use of that and use that to change how we display the temperature. Well, remember, earlier we created a forecast utils file. And in that file, we are passing in the temperature in Fahrenheit and then formatting that to 2 decimal places and returning a formatted string. So we're going to update this to take in a temperature display setting of either Fahrenheit or Celsius. And we're going to then make any necessary conversions, format the string, add the degree symbol to it, and this will let us update how our temperature is displayed. So to start, after we pass in the temperature, we're going to pass in a temp display setting. And now in our implementation, we're again going to use a when expression. We're going to type return when temp display setting. So because we have 2 different possible display settings, we're going to use a when expression based off of that temp display setting. And now we want to make sure we handle all the cases. And so if we put our cursor on when, we see this little red line prompting us that we need to handle each branch. If I type Alt-Enter, it'll show me some options, and one of those options will say add remaining branches. So I'm going to hit add remaining branches here, and it's automatically going to prompt me to handle both the Fahrenheit and the Celsius case. Now in the Fahrenheit case, we're going to do the same thing that we did before. So we'll pass string.format with 2 decimal places, and we'll pass in our temperature value. So that one is fairly straightforward. In the Celsius case, we need to do a bit more. So we're going to add open and curly braces here because we need multiple lines of code for this. And so the first thing we need to do is to actually convert our Fahrenheit temperature data into Celsius data. And so to do that, we will type val temp equals temp minus 32. We want to make sure this is a float value, so we add the little f. So in this case, that lowercase f means float, not Fahrenheit, times 5 float divided by 9 float. And then we're going to return string.format %.2f Celsius degrees and pass in temp. So this should now format our temperature properly based on the current display setting. So if we go to forecast details activity, we now need to update our invocation of the format temp for display function. So we can do that by passing in temp display setting manager dot get temp display setting. And now if we go ahead and go over to our daily forecast list adapter, we'll see that we need to do the same thing here in our view holder. So we could just create a new instance of temp display setting manager for each instance of the view holder. That would be the easiest way to go about this. However, it would be less efficient as well, because we'd be creating many instances of that object when we really only need one. So what we're going to do instead is create a temp display setting manager variable in main activity, pass it to the adapter, and then the adapter will pass it to the view holders. So if that sounds a little bit complicated at the moment, don't worry, we're going to walk through each step right now. So to start, we're going to add a new property here for daily forecast view holder. So it'll be a private val temp display setting manager property. So now that we have that, we can come down here into our bind method and pass temp display setting manager dot get display setting. So now this should properly format it to display Fahrenheit or Celsius. So we just need to continue passing that display setting manager to the appropriate places. So we have it in the view holder. The place where we create the view holder is our adapter here. So we're going to need to do the same thing in our daily forecast list adapter. We need to create a private val property for temp display setting manager. And now that we have that, we can pass that into the daily forecast view holder constructor. So one last place then to update this is to go to main activity, and we need to pass an instance of that temp setting display manager to forecast list adapter. So once again, we're going to create a private latent var temp, whoops, clicked on the wrong thing there, private latent var temp display setting manager. And just like in the forecast details activity, and at the top of onCreate, we will say temp display setting manager equals temp display settings manager this. So we've created our new instance of that, and now we can pass that into our adapter. So now if we run this, our code should compile. If we go over to our emulator, by default, it should be showing Fahrenheit temperature data displayed to 2 decimal places. If I go to our menu now here, I can select Celsius. And if I restart the app, and again, display some temperature data, now we see that things are showing in Celsius. And that is exactly what we would expect here. Now, one small thing to notice here is that in our forecast details, we're properly seeing a single line, but we we're still seeing the ellipsis there. So we're not actually seeing that this is temperature data. So let's go adjust this real quickly, just to be a little bit nicer looking moving forward. So again, forecast details activity. We're going to open up into our activity forecast details layout. And so because this ends up being quite large, even though we're formatting it to 2 decimal places, what I'm just going to do here is change this back to a display 3. So it's a little bit smaller. And then I'm going to remove the ellipse size property there, just because sometimes the ellipse size requires its own length and can truncate the last value possibly for you. And so if I run this one more time, it should look a little bit nicer for us. There we go. So now we're still have a lot of emphasis on the temperature, but things fit on the screen a little bit better. So at this point, we now have a working settings function. We can show a menu, we can click the display setting item, show a dialog, and get input from the user as to whether to show things in Fahrenheit or Celsius. And then on app restart, that setting takes place and we're updating to display using the selected setting. So one challenge with this though is that we can only access that menu currently from the forecast details screen and not from main activity. So let's quickly walk through how you could essentially copy the same implementation over to main activity so that we can have the same functionality on both screens. So if we look at forecast details activity and we just revisit what we did for the menu, remember the first thing we did was implement create options menu. The next thing we did was select on options item selected and implement that. And then we implemented this method to show the temp display settings dialog. So if we want to copy this over to main activity, we can actually simply copy and paste those 3 methods over to main activity. And if we do that and then select all of the imports, we should be able to rerun this. And if we switch over to our emulator, we now see that we have the menu on the main activity screen as well. So now this just gives us a more consistent experience across both screens in the app and makes it easier for us to update that display setting value. Now, if we wanted to manage this a little bit more easily, you might notice that our logic for how we are handling the temperature display setting dialog is duplicated in multiple places. We're doing it in both activities. So we could think about creating a helper method for this, similar to what we did for the temperature display formatting. So to start, I'm going to copy one instance of show temp display setting dialog. I'm then going to go over to our forecast utils function here, and I'm going to paste in that show temp display settings dialog method. And we should see a couple errors here. The first being that we don't have a context anymore because it's not within an activity. And the second being that we don't have an instance of a temp display settings manager. So we can fix both of those pretty easy by adding those as parameters to this function. So first, we'll say that we need a context. And then next, we will say that we need a temp display settings manager. And then instead of saying this when we need a context, we will pass in the context directly. So now we have a function that still will show this dialog and update the setting when needed. The only other thing we need to do is make sure that it's no longer private and instead is public. And now we can update both of our activities to use it instead of their own implementation. So I can delete this. And here in OnOptions item selected, I can call that same function, but now the one that's in the utils file. And I can pass in this, comma, temp display settings manager. And if I go to forecast details, I'll delete the specific implementation that was there. And I will paste over the same line of code we had before. And if we run this once again, we see that we still have the working dialog on both screens. So that's just one more way in which we are able to consolidate commonly used code into a utility function or some common class and then reuse it from multiple places.